Okay? So how many inches are there in 1 kilometer? 1.00 kilometers. Okay. So this is the problem. And the question is, how many inches? Okay? All right, so the first step, step 1, write what is given with the units given. Okay? So that's going to be this, 1.00 kilometer. You always start with what's given. I don't care how it's stated, if it's at the end of the problem or the beginning, just get that value, okay? Get the value that's given, because what you're doing is converting that value to a different unit. So you have to start with the given value, okay? The given value is everything. So that's 1.00 kilometers. Okay, that's step 1. Actually, I'm gonna do A before 1, and it's going to be map out the path. Map the path. Okay, what's the path? The path is all the steps you're going to take to get to your desired result. Okay, so here's the path for this one. We have kilometers, right? Kilometers. Oh, that's terrible. Wanted to add some color, and that was bad. Black works really well. Red works pretty good too. Kilometers. Okay? So our goal is to get to inches, right? So you have to think, and this is something you have to learn how to do. How do you get to inches from here? Now, what's given? You're given in the problem 1 inch equals 2.54 centimeters. Okay. So if I have to get to inches, I have to get to centimeters, right? So centimeters is going to be right before inches. So I have to get from kilometers to centimeters to inches now. Does everyone see that? So from kilometers, what did I teach you? Go to meters, right? Go to the base unit. What is the base unit of this problem? Raise your hand and tell me. Does everyone understand that that's the base unit? There's the base unit, and then there's the prefix, which is a value. Right? It's like a number, but it's a letter representing a value, right? So we're going to go to meters, and then from meters we're going to go to centimeters. There's your path right there. So that's what you're going to do. You're going to take one step at a time. You're going to go from kilometers to meters, from meters to centimeters, from centimeters to inches. Does everyone follow that? Okay? Now this path ends up actually being the numerator of your whole table. This ends up being the numerator, right? Because so the second step, so that was, let's just change the numbers. This is 1, write the path. 2, write what is given in the units. And now 3 is going to be, we're going to make our little table here, okay? So 3 is going to be fill in the table. Let's call it I'm just going to call it the table, okay? So you guys know what I'm talking about. The table with units only first, okay? Just do the units first. We're going to do the unit path, okay? We'll call this the unit path. We're going to do the unit path first. So now, if you've already mapped the path, this whole thing really is just the numerator. So you can go in and just write it all down. Here's the meter, right? Here's the centimeter. And then you end up with the inches. So does everyone see how the path that you've established is pretty much the key to everything? Once you've established the path, now you know what you're doing. That's your guide. Okay? Okay, so I'm going to go from kilometers to meters, from meters to centimeters, which is not so clean. centimeters to inches. All right? Everyone follow. Nod your head. Awesome. Okay. All right. So now the next step is fill in the rest of the denominator, basically, right? Which is the denominator is going to be what you're canceling out. Now, there has to be a relationship between the numerator and the denominator, because that's your unit conversion, right? So you can't just put anything over anything unless you're in a density problem. Okay, then they might be different in how you start, and we'll do that after. But for one unit to another unit, we're going to just, basically what you do is take the previous unit, which is this kilometer, right? And you're just going to put it down below the next place here, kilometer. So I have a relationship between meters and kilometers. Same base unit, right? I'm good. Same base unit, it's a conversion. So kilometers will end up canceling out. That's the goal. So then you're going to take the meters and drop it down here. Then you take the centimeters and drop it down there. Does everyone follow? All right, I didn't explain that well, so I want to make sure that was clear. So basically, so this is just another step. So you're filling in all the units. So now I have all of the units, and I'm going to check my units, make sure, check units to ensure all undesired units cancel out. And result is in desired units. Okay? So that's the third step. So let's do that. So we filled in the table with the units. I'm going to cancel out. Everyone see kilometers and kilometers cancels out, right? Kilometer over kilometer is 1, so that cancels out. Meters over meters is 1, so that cancels out. Centimeters over centimeters is 1, so that cancels out. The last unit is inches. That's what the problem is calling for, inches. So I know now that I've set up the problem correctly. You know, okay? This is how you know it's right. Okay, I'm on the right track, okay? Everyone good up to here? Okay. So I've run out of room to write step 4, so I'm going to use another board so we can keep it all alive here. Okay, step 4. Let's do this. Step 4, fill in conversion values. Now, I saw a bunch of people yesterday doing something which I thought was really smart. They went on their paper the second they got down to their exam. They're like, okay, I'm just going to put all my conversion values down on a little table and use them. Because it's helpful, right? So let's just do that. So I'd say, okay, 1 decimeter equals 10 to the minus, well, I wouldn't even use meter. I would say deci is 10 to the minus 1. Centi is 10 to the minus 2. Milli is 10 to the minus 3. Then we go to micro is 10 to the minus 6. Okay, and then pico was 10 to the minus 12. Oh, we did nano. Nano in there. Nano is 10 to the minus 9. Pico is 10 to the minus 12. So now you have your little table. You're all set. And you can say, okay, let me just do the other ones too. Now there's no way around this. You just have to memorize it. That there's nothing to figure out. You just have to get out your little cards, put them on the cards. You should work with each other and test each other and say, hey, what's nano? What's this? And I'm telling you that memorizing them in the exponent form is ideal for doing math, okay? To simplify your math and reduce error using the multiplication and division techniques I taught you using scientific notation, okay? It'll help you. And I saw a couple of you used zeros, you used your calculator solving the problems, and you made mistakes. And that's why you don't do that. Because entering 4 or 5 zeros, you're having to count zeros. It's why it's not recommended. So use scientific notation. So then the other side of things, we have what? Kilo, 10 to the third, and then what? Mega, 10 to the sixth, and giga, 10 to the ninth. Okay, so I have them all there. Awesome. Now, I'm going to go ahead and, now this is like when I say fill in conversion values, I think I'm going to stick a 4a in here, because I'm going to say write the relevant conversions that are needed. Okay? So we look at the problem, and what I mean is you're going to go, okay, I need a conversion from meter to kilometer, right? So I'm going to just write it on my paper. I'm going to say, okay, 1 kilometer equals 10 to the third meters. Just write it, okay? Because you've studied it, and I'm suggesting you always put a 1 in front of that prefix value, and then put the value of the prefix in front of the base unit, and just write it that way. That way they're in the right place right from the beginning, okay? So I need that one. I need centimeters and meters. 1 centimeter equals 10 to the minus 2 meters. What else do I need? Inches and centimeters. 1 inch equals 2.54 centimeters. Okay? So you can just do that. Put that little table on the side, right? So then you go back to your problem. Now I got my little table here on the side. I'm just going to use it. Okay, meter and kilometer. So now you're going to fill in the values, right? So it says 1 kilometer equals 10 to the third meters. Then I go to the next one. It says 1 centimeter is 10 to the minus 2 meters. And I say 1 inch is 2.54 centimeters. Okay. So do you see how valuable and easy it makes it if you just write those down? You don't have to think about it anymore. You've studied these values. You can just go, okay, 1 kilometer, kilo is 10 to the third, so it's 1 equals 10 to the third. And just write them 1, 1, 1. Use number 1 for everything with a prefix, and you'll always keep it in line if you study these numbers. Okay? So now I've just filled in all my values. So that was step 4. Step 5. This is fun. And use all these. It's a little one. Oh, somebody used the wrong marker on that one. Okay. I'll add it. I'm going to erase this little table, okay? Because everybody gets the idea there. And I'm going to erase this. Okay, step 5. Use logic and check all conversions. Say it out loud. Okay, what do I mean by that? Remember, I was going around yesterday, and people would write like 10 to the third kilometer. They would write 10 to the third in the denominator and 1 meter in the numerator, right? And I'd be like, say that out loud to yourself. Let logic catch your back, right? Because most people know that a kilometer is more than a meter, right? Because of Europe, and because we get that there's on your odometer you can see kilometers also, that it's some larger distance, right? So. And you know that a meter is like a meter, something like that. So if you said to yourself, 10 to the third kilometers equals 1 meter, you would catch yourself. You'd be like, that's just not right, right? And whenever you do that, you're like, there's something wrong there, right? So you've done your conversion wrong. So what you're going to do is you're going to go through each one and you're going to say it. 10 to the third meters equals 1 kilometer. That's how you check it. The numerator equals the denominator equals the numerator on your conversion factors. So 10 to the third meters, that's 1,000 meters, equals a kilometer. Is that true? Yes. Not only because I've studied it and I've memorized the numbers, but it makes sense to me. Okay? 1 centimeter equals 10 to the minus 2 meters. 10 to the minus 2, that's 1/100th. 1 centimeter is 1/100th of a meter. Yes, that's correct. 1 inch equals 2.54 centimeters. That's what was given to me. That's correct. Okay. You're there. If you've done all of that, you've gotten 90% of the points in that problem. If you make a calculation error, that's like a point off, okay? Or maybe a half point off depending on the problem. Because that's just manual work that you're making a mistake on. This is where the understanding is, okay? So now, what do you do from here? That's step 6. Do the math. So, only write numbers now. So what does that mean? Only write the numbers. So I'm going to say equals 1.00 times 10 to the third divided by 10 to the minus 2 times 2.54. That's what I mean by only write the numbers. Leave all the units off now because you've already found your final unit and it's going to be in inches. So you could write it at the end if you want to not forget it. Now that was just me translating the numbers. So we're going to add another step there. Everyone good? Everyone following? Yeah. Yeah. In the denominator, it's 10 to the minus 2. No, it's centimeters, so it's 10 to the minus 2 meters. It's this number here. And then 2.54. Does that step make sense to everyone? I'm just pulling out the numbers and putting them there so I can see them clearly, and I could just use my calculator and go for it. Okay, so now at this step, you can use your calculator and use exponents, right? And get your answer. And I always want you to check your answer using scientific notation multiplication method. So that would be step 6 or 7. Isolate the exponents and do simple math. And that's it. And then lastly would be express your answer with the right units. With units. Always put the right units and check your units in your answer. Okay. Well, I'll leave that up for a second. All right, so let's do that. Okay, so here we are. I'm going to erase this bottom area so we have a little bit more room to finish this problem. So this is going to be 1.00 divided by 2.54 times 10 to the third over 10 to the minus 2, right? So 1 over 2.54 equals what? $3.94. That's not 3.94. Yeah, let's just do just do this simple math right here. What is it? 0.394? Yeah. So I'll just leave it like that because I want to do every step. 0.394, okay? And then it's going to be times 10 to the 3 minus a minus 2. Does everyone follow that? So it's 3 minus the minus 2 because minus 2 is in the denominator, so you're going to subtract the numerator from the denominator. 3 minus the minus 2, that's 3 to the 5th, right? So you get 0.394 times 10 to the 5th. You're going to move the decimal over one place to get it proper scientific notation, and you end up with 3.94 times 10 to the 4th inches. And that's your answer. Okay, yeah. Going from where? Yes, yeah. Okay, so all I did was use my simple calculator, right, to get 1 divided by 2.54 right here, and the answer is 0.394, right? And I took this and I made it separate, and I just said times 10 to the 3 minus a minus 2, because that's how you do division with exponents, right? And then, so then my answer was 0.394 times 10 to the 5th. So proper scientific notation requires one whole number, then a decimal. So I have to move the decimal to the right, 1. Now, so is $3.94 bigger or less than 39 cents? Bigger, right? So I took it from 39 cents and I made it to $3.94, right? So I increased it by a factor of 10, which means I have to decrease the exponent by a factor of 10 so that the value stays the same. So from 10 to the 5th, I went to 10 to the 4th, right? Because 0.394 times 10 to the 5th equals 3.94 times 10 to the 4th. They're the same value. Does that make sense to you? Yes, that's standard, proper scientific notation. Yeah. That's right, because I moved the decimal. I changed the value of the number it's being multiplied by, so therefore I have to change the exponent, because I changed it by a factor of 10. Yeah. Yep. Yeah. Mm-hmm. Okay, any questions on this stepped procedure? Okay, so groups of 2 or 3, so get together. I'm going to give you a problem, and what I want you to do is work on it on your own first, then discuss what you did to get to your answer and compare your answers until you both agree on an answer, okay? And then I'll check with you and I'll go around and we'll see how you do. Okay, here's your problem. Now, if there's 2 people together that know what they're doing, then split up, okay? If you already have it mastered. So let's say, yeah. Okay, hold on, we have a question on the table. When you're adding and subtracting scientific notation, we didn't do that. We're only doing multiplying and dividing. Okay, so if you add and subtract 2 numbers like 2.8 times 10 to the 3rd plus 1.6 times 10 to the 4th, you have to make these both the same exponent to be able to add or subtract them. So you'd have to adjust this, right? So I would say, okay, well, it's going to be, I'm going to change this to 10 to the 3rd. How can I make that 10 to the 3rd? I would move this over 1, right? So it'd be 16 times 10 to the 3rd. Then you could say 16 plus 2.8, that's 18.8. But we didn't do that, but that's what you would do. And okay, here's a problem. How many? Let's do volume here. Let's say you have 4.72 gallons, and I want to know how many microliters that is, okay? So we need a conversion. So this is English to metric and metric to metric conversion. So I'm going to give you the gallon. What is it? I'll give you the gallon to liter conversion, and that is 3.785. That's right. So 1 gallon equals 3.785 liters. Okay, there you go. So that's the only English to metric conversion you need. Everything else are prefixes. So let's see how you do. This is microliters. Okay. Follow the steps. That's not true. Not following the steps. Write them out. Write out your conversions before you go putting them in. Awesome. That's right, but it's microliter to liter. Right? That's gallon, G-A-L, just so you know it's not G. It could get confusing. And liter to good. Awesome. And then do your math. And I don't know if the math is correct, but we can do that. Compare your answers with your partners. Yes. All right, we're seeing progress. So it's GAL. Gallon is GAL, the abbreviation. Awesome. Awesome. Yeah. You got it. Yeah, with 10 to 6 is in the denominator, it becomes in the numerator. That's right. Okay. Changing it up. That's fine. You're correct. It's just you're just doing it different than I showed you. That's fine. As long as you get it right. You did it different, so you did the same thing. Should get the same answer. Yeah, you got it. You have it set up right. You see, he's doing it different. He's saying, you say 1 microliter is 1 millionth of a liter. He's saying 1 million microliters is 1 liter. Same thing. Same thing. I'm suggesting you do it that way because you studied micro as 10 to the minus 6, and then do it consistently that way. So you should get the same answer. Yes, you do have it backwards. No, it's not on top. It's about the prefix. That's the prefix. That's right. It doesn't matter whether it's up or down. Yeah, that's what I'm given. So when you have a metric to English conversion, you just do what it says. 1 gallon equals that, right? When you have this, you put 1 in front of the prefix and whatever the prefix means in front of the base unit. So you did it backwards. Good.
Okay. Is that what it is?
That's awesome.
That's how I
Yeah, I would
Yours is wrong.
it out.
Okay.
See that?
Yeah.
That literally means 1/1 millionth
Oh,
of a microliter is 1 liter.
Okay.
1/1 millionth of a microliter equals 1 liter.
Okay.
No, right?
Yeah.
That's not right.
So this,
Yeah. Okay. You guys got one thing backwards. Say that. This equal this. Does that equal each other?
10 milliliters.
Those are microliters.
Microliters.
A microliter is 1/1 millionth of a liter. Micro is 1/1 millionth, 10 to the minus 6, right? So, does 1/1 millionth of 1/1 millionth of a liter equal 1 liter? 10 to the 6th, yes, not minus 6. But now what I'm
That was my bad.
Yeah.
She had it right, and
Yeah.
I was looking at mine,
Yeah.
and I
Can
saw
I use
minus
this?
6.
so what I'm teaching you to do is to always put. Can I use your pencil? Is to always put 1. This is micro, right? So I'm just gonna. That's not an M. It's micro. I always put 1 in front of that prefix. Doesn't matter if it's top or bottom. And then what does that equal? What does micro equal?
I see where you're going.
10 to the minus 6. Then you
Yeah.
put that below it or above it, depending. Just always do 1 in front of the prefix. And then whatever the prefix equals, you put it in front of the opposite base unit, wherever it is, numerator or denominator. And then you always get it in the right place. Okay.
so can you just skip, instead of going to milliliters, you can just go to microliters?
Yes, you do not have to go to
All right.
milliliters at all.
Making sure.
You shouldn't go to milliliters.
So, is
Yeah.
that right? I just,
Yeah, that's right. It's set up right. I don't know if you did the math right. I'll do the math up there.
all right.
Yeah, you do not have to go to milliliters. There's no reason to go to milliliters. You go to the base unit, then to the, and you're already in the base unit here, right? So from here, you have a conversion between micro and liter, right?
Right.
So you could just do that. There you go. Yeah. Yeah, no need to go to milliliter. No need to go to milliliter. Awesome.
So I just explained to her that could be 10 to the minus 6 or 10 to the 6.
Right.
Either
Yeah.
way works
Of course, yeah, as long as they're equal.
as long as they're
It's just that I'm training them to just do 1 as a way to make sure they're getting it correct and line things up until it's fully understood that you can do both, because I find it's too much. So because you're studying micro equals 10 to the minus 6th, you get that in your head, you say, okay, anytime I see a prefix, I'm just going to say 1, and then I know, and when you start to look at them, they're equal. It's just micro is the same thing as that number, so you're just doing 1 over the other.
Okay.
And its value should be 1. The numerator should equal the denominator. The denominator should equal the numerator when you're doing a conversion factor. Yeah.
So I set mine up different than she did.
Yeah, and yours is not correct. Yeah. What's wrong with that?
This.
Well, say it out loud. This is, well, put your unit here, liter, right?
Okay.
So what is that in a number? What does that mean? 1/1 millionth?
Okay.
And
Microliters and 1 liter.
so 1/1 millionth of a microliter equals 1 liter.
Oh, I see what you're saying.
You see what I'm saying?
Okay.
So that's not correct.
So it's not gonna work. Yeah. No, that's why I'm getting such a.
So do what I'm telling her. So put a 1 in front of it.
Okay. We were thinking it was the
Yeah.
same no matter what we did. And
Okay.
then- okay. Okay.
And then, okay.
For the rounding, so when we're rounding, if we go off this, right, where that's kind of like
Yes, the initial measurement, not the conversion factor. The measurement's what you round off of. All right. Okay, can I have everyone's attention again? All right, so we're going to learn from each other's mistakes here. So I see a huge improvement, which is awesome. Now, the one common mistake I'm still seeing is people putting things in the wrong places. And anyone who got it wrong I did not see them write their conversions out, okay? So here's what I'm going to tell you. If you're still doing that, then then write the conversions out that you need, okay? What I'm saying is this. We have our path, right? It's going to go gallon to liter to microliter, right? So I need a conversion from liter to microliter. So I'm going to write right here on the side, 1 microliter equals 10 to the minus 6 liters. Now I'm done. And as long as I do that correct, everything else is going to work in your table. Okay? Now, if you haven't realized yet, you can do this both ways. It's 10 to the 6th microliters equals 1 liter also. But now you have different numbers you're remembering, right? You're like, okay, micro's 10 to the minus 6 or 10 to the 6 or what? You know, you're just learning this. So you want to have a simple way to stay on track until it starts to be really familiar to you, okay? Because there's so many different learning points in this type of problem. Think about it. There are many different skills in this problem. There's math, right? There's scientific notation math. There's unit conversion values. There's canceling out units and lining up units. There's understanding the difference between metric and English. There's a lot of different points that you're trying to gather here. So when you first start, you want to just have a system that you follow. And then it'll just kind of be like, oh yeah, that makes sense, right? Because past the initial learning difficulty, it'll then make more sense. It'll be like, oh yeah, it's just a million. Like, that's what he's saying. Say it out loud so it makes sense, right? Because look, this literally says 10 to the 6 is a million, right? Micro is 1/1,000,000th. So a million, 1/1,000,000ths of a liter equals a liter. That's what this is saying. Does everyone follow that? And this says 1 microliter, which is a millionth of a liter, equals a millionth of a liter. 10 to the minus 6. 10 to the minus 6 is 1/1,000,000th. It's 1 over a million. Or 1 over 10 to the 6. Do you follow what I'm saying? So they are equals. So you can do them different ways. That's fine. It works. Like, that is true. There's nothing wrong with that. That works. It's just that it's a lot, and I suggest you do it simple steps till you get it. Okay? So do this. Write it out because you've studied that micro equals 10 to the minus 6. And then just apply it. Okay, so here we go. So we've done step 1, right? Write down what you're given. This is the value of what I was given. Wow. There it goes. This thing has issues, the guy told me. All right, so we're going to move to the board now. What's that? I confused the projector. It's dimensional analysis. Okay. Let me just, we have still a lot of time. So I'm going to go and move to the board, but I'm going to call them real quick and just tell them to get here.